So this problem wants us to find the particular equation. That just means like y equals ax squared plus, well, that's this right here. The particular equation of the quadratic function containing these points. So they gave us 3 points, and they want us to find the equation, that the quadratic equation that includes those 3 points. You remember how if I gave you 2 points, you could find a line?
Oh, yeah.
Well, if I give you 3 points, any 3 points, there's a unique parabola that contains those 3 points. Kind of like 2 points determine a line, well, 3 points determine a parabola. So how do you find that parabola? Well, it's a cool little trick. If you have a graphing calculator, that includes matrices. So these are my x's and y's over here, right? X, Y, X, Y, X, Y. So I'm going to place these x, y values in and make 3 different equations out of this. So my equation 1 is going to be with point 1. Equation 2 will be with point 2. Equation 3 with point 3. And just literally plug in your x's and your y's. So the y is negative 23. And the x is negative 1. So plug in negative 1 for x. What's negative 1 squared?
1.
Mm-hmm. Whoops, squared. What's b times negative 1 plus c? So what does this equal? Negative 23 equals a minus b plus c. There's one equation. Let's do that with another one of the equations now. Let's do that with this point. So equation 2 is going to be negative 13 equals, see where I got that from? Plug in 4a times 4 squared plus b times 4 plus c, which means negative 13 equals 16a plus 4b plus c. Got it? And the last equation we're going to use is is that 2 comma 1?
Yeah.
So equation 3 is going to be with 2 comma 1. So 1, that's my y value, equals 2 squared, which is 4a, plus 2b plus c. All right, so there are my 3 equations. I'm going to take those 3 equations and make a system of equations now. So equation 1 was negative 23 equals a minus b plus c. Actually, let me write them the other way because you're used to seeing it like this. A minus b plus c equals negative 23, right? 16a plus 4b plus c equals negative 13, and 4a plus 2b plus c equals 1. Now this is a system of 3 equations with 3 variables, and you could do this with Gauss-Jordan elimination method, all this that would take a page to do it. Or you could do it with matrices by converting this into a matrix equation by plucking off the coefficients. So this is called your coefficient matrix. See where I'm getting it from? See where I got those from?
Okay, yeah.
That's my coefficient. Well, you could. There's some calculators can do like what's called an augmented matrix. I prefer to do it this way because it's more makes sense algebraically. That's x, y, z equals, and there's my last one, negative 23, negative 13, positive 1. Okay. In your graphing calculator, punch this in and call it matrix A, and punch this in and call it matrix B. Notice that's a 3 by 3 matrix. A is a 3 by 3, and B is a 3 by 1 matrix. Okay, so you punch in your A and your B, then you clear out of the matrix window, and you go into the regular window, and you type in A. Well, you go back and get the matrix A. You type in A inverse times B equals, and it'll give you a matrix, a 3 by 1 matrix, and that's your x value, that's your y value, and that's your z value. X, Y, Z.
Going to be negative 3.
So your answers are
Negative 3.
negative 3, that's
11.
your x, 11, that's your y,
And negative 9.
and negative 9, that's your z. And there's your answers. X equals negative 3, y equals 11, z equals 9. So now I go back and I write it in that form. So y equals, remember x, y, and z were a, b, and c, right? They were actually not x, y, z, they were a, b, c. So a, b, c. So A is negative 3x squared plus 11x plus 9. There's your equation.
Yeah.
Oh, minus 9. Sorry. Thank you. Minus 9. And you can check it by plugging those values back in there, and sure enough, you'll see all three of those make the equation true.